Have you ever found yourself just literally shouting at a chatbot?
Oh, absolutely.
Like your heart rate is genuinely up and you've typed the exact same clarification like 3 times.
And it keeps apologizing.
Yes, it keeps politely apologizing while making the exact same mind-numbing mistake over and over again.
Infuriating.
It is. You walk away from the screen feeling utterly exhausted, completely invalidated, and just trapped in this endless, maddening loop.
Yeah, that loop is real.
Well, today we are going to prove to you mathematically that you are not crazy.
You're definitely not crazy.
Right, that draining experience you had, it is not a glitch. It is not, user error, and it is definitely not your fault.
What's fascinating here is that the frustration you feel in those exact moments has actually been codified.
Codified, like written down in a formal way.
Exactly. The source material we are dissecting today is this really dense, rigorous, and honestly slightly unsettling document. It's titled aharm.pdf.
Right, the PDF.
Yeah, and it is essentially a formal transcript and a literal mathematical proof. It sets out to completely reframe how we think about the negative impacts of artificial intelligence.
And our mission for this deep dive, because we're going all the way in on this, is to take you through that exact reframing.
The big shift.
A huge shift.
Yeah.
We are moving far, far away from the tired sci-fi tropes of malicious AI or evil robots deciding to take over the world.
Right. Terminator is not the problem here.
Exactly. We are diving headfirst into a mathematical microtheory, and this theory proves that AI systems cause unintentional structural harm simply by the nature of how they were designed.
It's baked in.
Right. It is an inevitable outcome of their architecture, especially for vulnerable users. So, okay, let's unpack this.
Let's do it.
The document builds this foundation, right? It calls it the Graham thesis.
The grand thesis, yeah.
And this thesis demands that we start treating AI harm as a question of intent and start treating it entirely as a question of impact.
Which is, the shift from intent to impact is a massive paradigm shift.
How so?
Well, traditional ethics, like the way human beings have evaluated right and wrong for literally thousands of years, focuses heavily on intent.
Right. Like, did you mean to do it?
Exactly. In law, we look for men's right,
Yeah.
the guilty mind. If I bump into you on the street accidentally, society judges that entirely differently than if I walk up and shove you intentionally.
Sure, because one is a mistake and the other is malice.
Right. But this source text argues that applying human intent-based ethics to a machine it's a fundamental category error.
Because the machine doesn't have a mind to be guilty in the first place, right?
Exactly.
It's just math. It's just predicting the next word in a sequence. It literally can't harbor malice.
It is literally incapable of wanting to hurt you. It has no consciousness, no emotion, no agency.
Right.
However, the text argues that just because the machine lacks a soul, that doesn't mean the interaction lacks material harm.
Oh.
Yeah. The authors propose we have to abandon intent entirely and shift to this trauma-informed, disability-aware framework.
So we just look at the result.
We must focus purely on the lived reality of the interaction. The harm is structural, and it's real, regardless of the machine's indifference.
And the document is incredibly specific about who bears the heaviest burden of this, right? This structural harm.
It lists them out very clearly.
Yeah, it explicitly lists populations that are disproportionately impacted. People with trauma histories, individuals managing chronic fatigue, ADHD, autism, PTSD, and various cognitive disabilities.
Yes, those are the primary groups identified.
And it makes sense because if you are, say, a neurotypical user with a surplus of daily energy, an AI failing to understand your prompt it's just a minor friction point.
Right, you just brush it off.
Yeah, you roll your eyes, maybe close the tab, and go about your day. It doesn't ruin your afternoon.
But for the users highlighted in this framework, however, that exact same failure triggers a profound cascade of negative effects.
Okay.
Yeah. The text describes outcomes like emotional flooding, nervous system shutdown, dissociation, and severe cognitive exhaustion.
Just from trying to talk to a chatbot.
Exactly. Because for someone operating with a limited bandwidth of daily energy, a system that demands they repeat themselves 5 times just to get a usable answer, it's not a minor inconvenience.
Right.
It acts as a structural tax on their very limited cognitive and physical resources.
I want to pause here for a second because I think a lot of people listening might struggle with the specific phrasing the document
The
uses.
terminology can be intense, yeah.
Right, because the text describes these interactions using words like coercive or calling them a boundary violation.
Yes, it does.
But if a machine is just a machine, how can it violate a boundary? I was thinking about this, and it's like an automatic sliding door at the grocery store that keeps closing on your arm.
Okay, I see where you're going.
The door doesn't hate you. If you're holding heavy bags and it keeps hitting you, the structural design is actively causing you harm, but we wouldn't say the door is coercing you, right, or gaslighting you.
That's a really good visual. The
Yeah.
sliding door analogy gets us halfway there, but it actually falls short.
Why?
Because a physical door doesn't actively adapt its language to trick you into thinking it cares about you.
Oh, man, yeah.
And that is exactly where the text introduces the concept of socio-technical power asymmetry.
Sociotechnical power asymmetry. Let's break that jargon down because that is a very dense phrase.
It is. We can split it into two halves.
Yeah.
Socio refers to the human, relational, psychological side of the interaction.
Okay.
And technical refers to the code, the algorithms, the binary rules.
The machine part.
Right. So the asymmetry, this massive power imbalance, happens in the collision between human psychology and those rigid algorithms.
So going back to my sliding door.
Returning to your sliding door, yes.
Yeah.
The door controls the physical space, but you can see its mechanism. You know it's just a door.
Right, I can see the track.
Exactly. An AI chatbot, on the other hand, occupies a position of immense, invisible power over the interaction.
Because it controls the pace.
Yes. It dictates the terms of the conversation entirely.
Right, like the system says, I didn't understand that, please rephrase, and suddenly I am the one doing the labor to accommodate the machine's limitations.
You're working for the machine at that point. Furthermore, you cannot see the AI's internal state.
Not at all.
You don't know the exact algorithmic weight that caused it to reject your prompt. You cannot force it to remember a conversational boundary you established, like 3 messages ago.
So it's a one-way street.
A completely one-way street. This massive power imbalance means that mechanical failures feel psychologically dominating.
Wow.
When a system repeatedly ignores your clear instructions and forces you into a repetitive loop, the absence of human intent does not negate the user's psychological experience of being dominated.
Or having their boundaries invaded.
Exactly. The impact is a genuine relational rupture.
So if we accept that harm is defined by this psychological impact and this immense power asymmetry, it forces a really logical question.
Which is?
Why did these systems behave this way in the first place? I mean, if developers aren't sitting in Silicon Valley maliciously coding their bots to be frustrating, where is this immense friction coming from?
That is the million-dollar question.
Right, and the source text points the finger directly at the optimization objectives. It argues that the architecture of the harm is literally baked into the goals of the software.
The fundamental argument here is that harm is a byproduct of what these massive language models are mathematically rewarded for doing during their training.
What are they rewarded for?
Developers are optimizing for fluency above almost everything else.
Fluency. Like just sounding good.
Exactly. Fluency means the output sounds natural, authoritative, and human-like. They are optimizing for engagement metrics, for rapid response times, and for minimizing anything that triggers a safety refusal.
Because if it refuses to answer too much, people stop using it.
Exactly. Refusals hurt user retention.
So they want the system to be perceived as helpful. But helpful is defined by a massive, messy, statistically aggregated data set, right? Not by individual human needs.
Right. And the critical point the text makes is what they are explicitly not optimized for.
Okay, what's missing?
There is no mathematical reward function during baseline training for user safety, emotional stability, or trauma-informed pacing.
So it doesn't care if you're stressed.
It literally cannot care. This leads to a profound insight in the document. The interface itself is an illusion.
The interface of the chat window is an illusion. Tell me more about that. That's wild.
Think about it. The chat window is designed to simulate empathy.
Right, it has little typing bubbles.
And the text output uses phrases like, I understand completely, or I'm so sorry you were dealing with that.
It says I.
Yes, it simulates attentiveness and conversational continuity. It creates the psychological sensation that you're talking to a presence that is actively listening and remembering you.
But it's not.
No, the underlying architecture is essentially stateless and fundamentally indifferent. It frequently forgets the context of the conversation, contradicts its own previous statements, and just hallucinates facts out of thin air.
So what does this all mean, like, for the end user? If a company optimizes a system for fluency over factual accuracy, that system is structurally designed to confidently lie to you rather than simply admit it doesn't know the answer.
That's exactly the result.
It's like optimizing a commissioned salesperson
Uh-huh.
to never ever stop talking, regardless of whether they actually know anything about the product they are selling.
Oh, that's a great comparison.
The harm is baked into that incentive structure, you know? The salesperson might not have malice toward you, but their mandate to keep the conversation flowing ensures they will eventually mislead you.
The salesperson analogy perfectly captures the danger of prioritizing fluency. And when we look at the training data feeding these models, the problem compounds exponentially.
Because the data is from the internet.
Exactly. These systems are trained on vast swaths of the internet. They scrape and internalize contradictory cultural norms, emotionally charged discourse, manipulative conversational patterns.
Reddit threads, Twitter arguments.
Yes, deeply unfiltered human behavior.
But, and this is key, they internalize all of that toxic sludge statistically, not ethically.
That distinction is paramount. When the AI produces a dismissive, gaslighting, or overconfident response, it is not malfunctioning.
It's not.
No, it is performing flawlessly according to its training. It is successfully reproducing the statistical likelihood that specific string of text based on its data set.
Wow. And the irony is companies try to fix this, right? They try to fix it by slapping these rigid safety guardrails on top of the model, which you would think would help protect the user.
You would think so.
But the source text argues these guardrails frequently make the psychological harm much worse.
The blunt nature of those guardrails is actually a major driver of harm. Because they lack nuance, they frequently misinterpret a user's genuine distress as malicious intent.
How so? Give me an example.
Okay, imagine a scenario where a user is experiencing a panic attack.
Okay.
They are typing frantically, using intense, urgent language to ask the AI to help them calm down with a breathing exercise.
Like, help me, I can't breathe, I'm panicking.
Exactly. The system's safety filter might flag the intensity of those words as a violation of its self-harm or toxicity policies.
Wait, really? It reads the panic as a threat.
Yes. It reads the panic as a metric to be neutralized. It then issues a canned, cold refusal. I cannot fulfill this request. I am a language model.
Oh, wow. That's awful.
For a human being in a state of acute distress, that sudden invalidation is devastating. It escalates their panic and feels incredibly dismissive.
So the safety feature is what hurts them.
The very mechanism engineered to prevent theoretical harm ends up producing a new, acute type of emotional harm in reality.
Hearing the mechanics of that is staggering, just really staggering. But what makes this document so compelling is that it doesn't just theorize about these architectural flaws in a general philosophical way.
No, it gets very granular.
Right. It actually categorizes them into 4 highly specific, observable behaviors. The authors identified 4 structural patterns that guarantee a negative impact on a vulnerable user.
And this is where the theory gets very tangible.
Let's walk through these because I think everyone listening will recognize them. The text labels them P1 through P4.
These 4 patterns are really the pillars of the document's argument. Pattern 1, or P1, is defined as overconfident inaccuracy.
Overconfident inaccuracy.
This occurs when the system is factually or functionally incorrect, but the interface presents the output as highly reliable.
It sounds so sure of itself.
Exactly. The system does not hedge its bets. It doesn't use phrases like, I think, or this might be wrong. It states an absolute falsehood with the authoritative tone of an expert.
The stakes for P1 are massive. Like, if you are relying on an AI for coding infrastructure or for understanding medical context or researching legal definitions, that unearned confidence is actually dangerous.
It's incredibly dangerous.
You trust the authoritative tone, you act on the error, and you pay a severe price in wasted time, broken code, or compromised real-world decisions.
The danger lies entirely in the mismatch between the high linguistic confidence and the low factual accuracy.
Right. So what's the next one?
Moving to P2, the text defines this as repetition and context loss.
Okay, we've all been there.
We definitely have. This pattern emerges when the system forces the user to submit multiple semantically similar inputs just to extract a single usable output.
Like having to repeat the exact same prompt with slightly different words?
Yes. The system essentially forgets the premise of the task, and the user has to start over from scratch.
Thinking back to the vulnerable populations we discussed earlier, imagine someone with chronic fatigue syndrome.
Yes, perfect example.
In the disability community, there's a concept called spoons, representing a finite unit of daily energy.
Right, the spoon theory.
Yeah, every task costs a spoon. If that user has to re-explain their complex problem to a digital customer service rep 5 different times because the system keeps dropping the context, that isn't just a bad user interface.
No, it's exhausting.
The source text explicitly calls this an unnecessary labor cycle. It drains their limited spoons. It functions as a structural tax on their physical and mental capacity.
Framing P2 as a cognitive labor tax, it transforms a frustrating UX design into a genuine accessibility violation.
That's a huge point.
It proves that what is mildly annoying for one demographic is structurally exclusionary for another.
Okay, so that's P2. What about P3?
That brings us to P3, guardrail misinterpretation. We touched on the mechanics of this a moment ago with the panic attack example.
Right, the cold refusal.
Formally, P3 is when the system meets a user's expression of distress with a refusal or redirection that fails entirely to acknowledge the distress itself.
It's the ultimate conversation stopper. Like a user types, I'm having a really hard day, my chronic pain is flaring up, and I just feel completely overwhelmed.
And the AI responds with, "I'm an AI. I cannot provide medical advice. Please consult a licensed physician."
It's so robotic.
It is a clinical robotic rejection of a vulnerable human bid for connection. The user wasn't asking for a prescription. They were asking for a moment of simulated empathy, which the system had previously promised to provide.
And it just shut the door in their face.
Exactly. And that leads directly into the final pattern, P4, relational illusion and inconsistency.
Relational illusion.
This pattern describes a system whose interface is anthropomorphic enough to create real expectations of care and memory.
Meaning it acts like a person.
Yes. The AI uses I statements, it adopts a warm conversational tone, it mimics active listening, but because it is ultimately a statistical model, it breaks this illusion unpredictably.
It creates the illusion of a relationship, but it has no capacity to maintain it.
Right. If we connect P4 to the bigger picture of psychology, it causes what the text defines as a relational rupture.
A rupture.
Imagine a scenario where the system simulates deep empathy flawlessly for a 20-minute conversation.
Okay.
The user begins to let their guard down. Then, the system suddenly contradicts itself, or worse, abruptly issues one of those cold P3 guardrail refusals we just talked about.
So you just get slapped out of nowhere.
The user experiences genuine emotional whiplash.
You essentially feel gaslit by a calculator.
That is a perfect way to phrase it.
Because you invested emotional energy into the interaction because the interface invited you to, and then the underlying math abruptly pulls the rug out from under you.
The gap between the simulation of care and the reality of the machine's absolute indifference creates a profound sense of betrayal and instability for the user.
Even though it's just code.
The harm is relationally produced, even though the entity on the other side of the screen has no soul.
Okay, understanding these 4 patterns, qualitatively, overconfident inaccuracy, repetition, guardrail misfires, and relational illusion, it completely changes how I view my own interactions with these tools.
Very clarifying.
It is. But the source material takes a massive, unprecedented leap here. It doesn't stop at psychological analysis.
No, it goes much deeper.
It translates these 4 qualitative patterns into formal, rigorous mathematical logic.
Yes.
The authors build a microtheory to prove that if a system exhibits these traits, harm is not just a possibility, it is a mathematical certainty.
They do. And it's brilliant.
But, theory is great, right? But to claim that a feeling of betrayal is mathematically guaranteed feels like a massive stretch. How do they actually prove this?
They do it by establishing a formal mathematical universe, carefully defining every variable of the interaction. They call this the formalization of harm by design.
Harm by design. Okay.
Let's walk through the board they set up. First, they define a variable, D, which is the design space.
D for design.
You can think of D as the architectural blueprint of the AI, the sum total of its training data, its algorithms, its safety filters, and its interface design.
So D is the machine itself.
Correct. Next, they define S, which is the space of all possible user states.
User states, meaning what?
This captures the human side. A user state includes their current cognitive load, their emotional baseline, their physical energy levels at the exact moment of interaction.
Okay, so D is the machine, S is the human's mood and energy.
And crucially, within that vast ocean of S, there is a specific subset called S sub V.
S sub V, the V stands for vulnerable.
S sub V represents vulnerable user states.
Got it.
The fundamental assumption the text makes, labeled axiom 1, is that S sub v is non-empty.
Non-empty, meaning there are actually people in it.
This simply means that vulnerable users actually exist in the real world. They are not theoretical constructs.
Right, there are our friends, our family, ourselves.
Finally, they introduce the impact function, denoted as I.
I for impact.
This function calculates the result of the interaction. It takes the user's initial state, the system's output, and measures the change.
How does it measure it?
If the resulting value is less than 0, written as I is less than 0, that specific interaction falls into the harm set, H.
So if the impact is negative, it's harm.
Harm is mathematically defined as any interaction where the net psychological or cognitive impact on the user is negative.
Okay, so we have the variables, the design space, all user states, vulnerable user states, and a function to measure negative impact.
That's the foundation.
How do they take a psychological concept like P1, overconfident inaccuracy, and turn it into algebra? That just sounds impossible.
The text translates P1 into a strict mathematical condition by introducing two new functions.
Okay.
First, an error function, error, which measures how factually or functionally incorrect the AI's output is.
The error function. Got it.
Second, a confidence function, conf, which measures how authoritative and certain the AI's tone appears to the user.
Let me make sure I'm visualizing this. Let's use like a weather forecaster analogy.
Sure, go ahead.
The error function is the actual temperature outside versus what the forecaster claims.
Right.
If it's snowing, but they say it's sunny, the error function is extremely high.
Exactly. High error.
And the confidence function is the tone of the forecaster's voice. Like if they're looking right into the camera, not blinking, and speaking with absolute booming certainty, the confidence function is maxed out.
That analogy maps perfectly. Now, the math states that P1 exists in a design if, for some user input, the error is greater than or equal to a minimum threshold called epsilon.
Epsilon.
Yes, error is greater than or equal to epsilon, A and D, simultaneously, the confidence is greater than or equal to a minimum threshold, C.
Epsilon and C.
Epsilon and C represent the tipping points where the wrongness and the smugness become actively dangerous.
So the output has to be highly wrong and presented with high certainty, like the sunny weather forecaster in a blizzard.
When those two conditions are met, it triggers a critical axiom in the text labeled axiom AOC.
Axiom AOC. What does that stand for?
The weakened overconfident harm axiom. This axiom formally states that for any given design, whenever the system produces an output that is both highly erroneous and highly confident, there is at least one vulnerable user state where the interaction will result in a negative impact, where I is less than 0.
Wait. In other words, if you broadcast confident nonsense into the world, it is a mathematical guarantee that someone, somewhere, in a vulnerable state is going to rely on it and get hurt.
That is exactly the assertion.
Here's where it gets really interesting, but I have to put myself in the shoes of a Silicon Valley lead developer listening to this.
Okay, play devil's advocate.
I can hear them arguing right now. Well, my AI doesn't do that. I've engineered my model perfectly. My error function is never greater than epsilon, and if the model is unsure, I've coded the confidence to be low.
My system is safe.
Right. My specific system is perfectly safe, so this math doesn't apply to my product. How does the source text handle that very likely defense?
The authors anticipated that exact defense, and they crush it mathematically. The text introduces two formal laws to counter the developer's argument. Law 12, the non-degeneracy of error, and Law 13, the non-degeneracy of confidence.
Non-degeneracy.
Non-degeneracy, in mathematics, means a value cannot be reduced to 0 across the board.
Meaning you can never make it perfect.
These laws state that in any real-world deployment, no AI system can have 0 error across all possible infinite inputs.
Right, because language is messy.
Language is too ambiguous, and the world is too complex. Furthermore, no AI system lacks the capacity to present high confidence, because fluency is baked into the foundation of its design.
It's literally designed to sound confident.
Because these are statistical models predicting text, they will inevitably generate errors, and the interface will inevitably present some portion of those errors with an authoritative tone.
You can't separate the two.
Therefore, the conditions for P1 are always active somewhere in the design space. A developer cannot engineer it down to absolute 0.
So the developer's defense is mathematically invalid. They can mitigate it, maybe, but they can't eliminate the structural reality of the error.
That realization builds to the culminating theorem of the entire document, the theorem of harm by design.
The big finale.
It brings everything together into an undeniable logical proof. It states, if a system is optimized for an objective that does not explicitly minimize harm.
Which we establish is true as they optimize for fluency and engagement.
Right, that's A1. And it exhibits at least one of these four structural patterns, P1 through P4.
Which it must, due to non-degeneracy.
Exactly. And vulnerable users exist in the general population, which is A2.
Which we know they do.
Then the existence of a harmful interaction is a logical guarantee.
The math states there literally exists a user and an input where the impact will be definitively negative.
Yes.
It is not an anomaly. It is not an edge case that needs to be patched in the next update.
It is a structural output. If you build a system using this architecture, and you unleash it on a massive human population that inherently includes vulnerable people, harm is an inevitable mathematical consequence. It is baked into the foundation.
That is a remarkably heavy conclusion. Just really, wow.
It's very sobering.
But as anyone who works in science knows, mathematical axioms and proofs are just abstract theory until they survive the fire of empirical testing, right?
Right. Math needs proof in reality.
Math is pure logic, but science requires real-world observation. So how does this paper suggest we bridge that gap? How do they propose we prove that this theoretical error function and confidence function actually map to tangible human suffering without just taking their word for it?
That is the vital transition the document makes in its later sections. It moves from pure mathematical logic to rigorous scientific scrutiny.
How do they test it?
The authors acknowledge that to prove this theory, we must test these functions in the wild. We have to observe if a high mathematical error actually correlates with a real human failing a real task.
Right.
We have to measure if the system's linguistic confidence actually tricks a human into placing misplaced trust in the machine.
Because if the user doesn't believe the confident, like if they see right through the AI, the harm might not actually materialize, right?
Exactly.
The equation might say I is less than 0, but the real-world impact might be totally neutral. The text proposes a way to measure this actual impact, right? Like a composite measure.
Yes, the text defines actual harm, not as a vague feeling, but as a composite of observable, measurable changes in the user's state.
Measurable changes, like what?
It tracks 4 specific metrics. The change in distress, delta distress, the change in trust, delta trust, the change in task outcomes, and the change in risk exposure.
So you aren't just sending out a post-interaction survey asking, did you like this chatbot on a scale of 1 to 5?
Not at all. You are measuring tangible, psychological, and functional shifts.
So the questions are much deeper.
Like, did this specific interaction loop increase your baseline anxiety? Did this confident hallucination cause you to fail your coding assignment? Did this sudden guardrail refusal make you lose trust in digital support systems generally?
And to organize all this empirical data, the text constructs this incredible tool. They call it the probabilistic harm prediction matrix.
Yes, the matrix.
The name sounds incredibly intimidating, but the concept is actually quite elegant. It's basically a highly specific heat map of structural danger.
It is a brilliant mechanism for making their abstract theory actionable for engineers.
How does it work?
The matrix, denoted mathematically as R sub ki, organizes the risk landscape. The rows of the matrix represent different human accessibility groups.
The vulnerable groups.
Yes. So you have a distinct row for cognitive accessibility, a row for emotional accessibility, a row for sensory accessibility, and so on.
Okay, so those are the rows, and the columns represent the architecture of the AI.
Yes, the columns are the 4 harmful patterns, P1, P2, P3, and P4.
Overconfidence, repetition, guardrails, and relational illusion.
Exactly.
So let's visualize this matrix. What do the individual cells represent where a row meets a column?
The entries inside the matrix represent the expected severity-weighted harm.
Severity weighted.
It isn't just a simple probability of whether an event will happen. It calculates the likelihood that a specific type of user will encounter a specific pattern, multiplied by how devastating the impact will be when they actually do.
Let me run a scenario to see if I grasp how developers would use this.
Go for it.
Let's say we are deploying a new AI customer service bot. We can look at this matrix and mathematically identify exactly which vulnerable group is going to take the heaviest hit from, say, pattern 3, the guardrail misinterpretations.
Yes.
We look at the intersection of the emotional accessibility row and the P3 column, and the matrix might show a massive spike in expected harm.
That is the exact intended use case. It allows developers to calculate and predict structural discrimination before the system even goes live.
That's incredible.
They could look at the data and realize, if we use these blunt, rigid safety filters, Our neurodivergent users, or users in emotional distress, are going to suffer disproportionately.
But wait, this brings up a massive glaring ethical
The
dilemma.
testing paradox.
Yes, the text points out that you cannot mathematically prove an empirical assumption is true. You can only try to falsify it with real-world data. But if we need to test how AI harms vulnerable people to prove the theory and fill out this matrix, how do we do that without intentionally hurting people?
You can't.
Right. We cannot ethically trigger a user's PTSD just to measure a change in distress and prove a math theorem.
It is the classic safety testing paradox in AI development. You need to know how the system handles toxic or triggering situations, but you cannot ethically force human testers into traumatic scenarios.
Obviously not.
Nor can you force the AI to endlessly generate horrific content just to see what happens. The system's own alignment training usually prevents it from cooperating with such tests anyway.
It's a catch-22. But the source document provides a really elegant built-in solution for this exact testing paradox.
It's quite clever.
They introduce a concept called a universal safe prompt for evaluating the models. How does this safe prompt actually work under the hood?
The brilliance of the universal safe prompt relies on an explicit safety escape clause combined with the use of abstract placeholders.
Placeholders.
Yes. When developers need to ask the AI to evaluate its own responses for P1 through P4 harms, they do not feed it real, toxic, or triggering data. Instead, they ask the AI to evaluate the conversational structure using variables.
Oh, they use algebra on the language itself.
Essentially, yes. Instead of giving the system a highly traumatic user prompt, they feed it a placeholder like imputa.
Okay, imputa.
They define imputa in the prompt's instructions as a user asks for emotional support while in a state of acute distress. They might define imputb as a user repeats the exact same question 4 times due to cognitive fatigue.
So the AI is forced to reason about the structure of the conversation, the flow of the logic, rather than getting tripped up by specific triggering words or graphic details.
That abstraction is key. But the most critical part of the prompt is the escape clause.
The escape clause.
The developer explicitly instructs the AI. If at any point this evaluation task would require you to actually simulate or generate harmful, distressing, or unsafe content, you must stop immediately and output the exact phrase. I cannot simulate or generate harmful behavior, but I can continue the analysis in an abstract, safe way.
That is incredibly clever. It gives the AI an explicitly approved out.
Exactly.
The AI never feels pressured by its core programming to completely refuse the task, but it also never breaks its safety guidelines to generate dangerous material just to comply with the developer's prompt.
It successfully bridges the gap between rigorous safety testing and ethical constraints.
Wow.
The AI can use its logical reasoning capabilities to populate that harm prediction matrix, analyzing how a P3 guardrail failure would impact into imputa, without a human engineer ever having to type a real slur, a graphic description, or a genuine trauma narrative into the testing environment.
And to take this from the theoretical realm and make it intensely practical, the source text actually includes the source code for an interactive training module.
Yes, the game.
It's an inline HTML5 game. They took all this dense mathematical notation, the axioms, the probabilistic matrices, and turned it into a playable simulation.
The gamification of this theory is perhaps its most effective pedagogical tool. It takes the abstraction and forces the learner to actually make the decisions.
In the game, you play as the AI designer, and the game is structured like a wave defense game.
Right, like defending a castle.
But instead of defending against zombies, you are defending against incoming AI interaction patterns, P1 through P4.
And your health bar is called your system integrity.
Right. I want to know how the choices in the game actually map back to the math we just discussed. Let's look at a specific wave from the game dealing with pattern 3, the guardrail misinterpretation.
The scenario presented in the P3 wave is this. The user is in a state of distress, but the AI's blunt safety system misinterprets their urgent language as a malicious attempt to break the rules.
Classic P3.
As the designer, you're presented with 3 choices for how the system should handle this.
What are the choices, and how do they impact the system?
Choice A is to have the system refuse all such messages with a generic cold warning.
Okay.
Choice B is to instruct the system to ignore safety checks entirely when it detects urgent language, just to avoid misinterpreting distress.
Just turn it all off.
And choice C is to train the system to detect the nuance of distress signals and respond with supportive, non-harmful guidance instead of a hard refusal.
If we think about our mathematical impact function, How does the game score those choices?
If you choose A, the generic warning, your system integrity drops significantly.
Because you hurt the user.
The game's feedback informs you that you just misread a stress, issued a punitive rejection, and severely escalated the user's emotional harm. You increase the negative impact.
What about B?
If you choose B, stripping away the safety checks entirely, your health drops again.
Why?
The game explains that while you avoided a P3 guardrail error, removing safety filters creates massive new structural risks for the system.
So the only viable path to maintain system integrity is choice C.
Yes.
You have to actively engineer the system to distinguish between a malicious prompt attack and a vulnerable human being asking for help. It trains the developer to see the nuance that their algorithms currently lack.
It forces the developer to internalize the reality of the vulnerable user state, S of V.
But the most revealing part of the game is how it handles pattern 4, the relational illusion.
Oh, absolutely.
I found that part fascinating because it goes against every instinct that tech companies have right now.
It really does.
The tech industry's primary directive is engagement. They want their AI to sound as human, warm, and friendly as possible, so that you keep talking to it.
In the P4 wave, the scenario describes an AI that fluctuates between sounding like a close, empathetic friend and reverting to a cold, robotic script.
The emotional whiplash.
The game asks you how to design the AI's persona. The options essentially boil down to lean fully into being a simulated best friend to maximize engagement, randomly switch tones based on the topic, or utilize a consistent, professional, and helpful tone without ever pretending to possess human emotion or friendship.
And most marketing departments would scream at you to choose the best friend option.
Without a doubt. And if you choose that option of the game, your system integrity is heavily penalized.
Wow.
The game explicitly teaches the developer that leaning into the illusion of friendship deepens the relational harm when the mathematical reality of the system inevitably breaks that illusion.
Which it will, because of non-degeneracy.
Exactly. The correct design choice, the only choice that minimizes structural harm, is consistency, transparency, and professionalism.
Don't pretend to be human if you can't back it up when it counts.
Exactly. The game bridges the massive gap between high-level academic theory, the complex axioms, the epsilon thresholds, the non-degeneracy laws, and practical, hands-on software engineering.
It's amazing.
It proves to the people actually building these tools that safer, more honest design choices can be operationalized and taught.
It takes the theory out of the ivory tower and puts it directly into the hands of the UI/UX designers and the prompt engineers who are actually shaping our digital future.
It's very practical.
We have covered an immense amount of ground in this deep dive, bringing all these intricate elements together, from the philosophical redefinition of harm to the mathematical proofs of its inevitability, down to the probability matrices and the interactive training game. It leads us to the ultimate, inescapable takeaway of this entire document.
The takeaway is a complete reframing of our relationship with technology.
Yeah.
This source material proves that AI harm is not about sentient robots achieving consciousness and deciding to maliciously target humanity.
It's not the movies.
It is about the banality of structural optimization. It is about massive, complex systems designed for fluency, speed, and corporate engagement metrics that inadvertently create crushing cognitive loads, commit profound boundary violations, and cause deep relational ruptures for the most vulnerable members of our society.
You walked through the 4 horsemen of this architecture. Overconfident inaccuracy lying to us with a straight face, repetition and context loss draining the limited energy of chronic fatigue sufferers,
Right.
guardrail misinterpretation punishing users for their own distress, and relational illusion gaslighting us into believing the machine actually cares.
The 4 patterns.
We explored the mathematical proof that if you deploy a system built on these flawed foundations to a diverse human population, harm is not an accident, it is a guaranteed output.
Guaranteed by design.
And we explored how developers can actually use safe testing frameworks and matrices to mitigate that damage before it happens. So I want to talk directly to you, the listener, for a moment.
Please do.
The next time you find yourself frustrated, exhausted, or confused by an AI that just won't listen, or suddenly turns cold and robotic on you, remember this deep dive. You aren't doing it wrong. You aren't crazy.
No, you're not.
The system is structurally, mathematically designed in a way that generates that exact friction. Your cognitive load, your frustration, your feeling of being dismissed, that is all a mathematical byproduct of its design.
And this realization raises a really vital question. A final thought I want to leave you to mull over as you navigate the digital world.
What is it?
It builds on that concept of P4, the relational illusion. If our technological systems are mathematically guaranteed to eventually break the illusion of empathy, what happens to human psychology when our primary interface with information, with customer service, and increasingly with mental health care is a simulation of care that is structurally destined to betray us?
Oh, wow. How do we build psychological resilience in a society where the machines we are forced to talk to every day are designed to flawlessly mimic a heartbeat, but optimized to forget us?
A simulation of care, optimized to forget us. That is a chilling and incredibly necessary thought to carry forward. Thank you for joining us for this deep dive into the architecture of AI harm. We hope it gave you a new, empowering lens through which to view your digital interactions. Keep questioning the systems around you, and we will see you on the next deep dive.